Hello everyone. In this video, you are learning about special products that is called identities. Let us consider x plus 3 is equal to 5. You know that x takes the value of 2. It is only true for x is equal to 2. This type of statements are called conditional statements, where the condition being x is equal to 2. For example, take a plus b whole square is equal to a square plus 2ab plus b square. So first let us take a is equal to 3 and b is equal to 2. So for example, if when I am taking a is equal to 3 and b equal to 2, you can observe LHS is equal to 25 and RHS is equal to 25. It's verified. Let us take a is equal to minus 1 and b is equal to minus 2. So now again a plus b whole square is LHS. A square plus 2ab plus b square is RHS. Both LHS and RHS are equal. So the above equation is true for all values of a and b. Such type of equations are called identities. So what is identity? An identity is an equation which is true for all values. So let us see identity 1. A plus b whole square is equal to a square plus 2ab plus b square. Identity 2. A minus b whole square is equal to a square minus 2ab plus b square. Identity 3. A square minus b square is equal to a plus b into a minus b. Identity 4. X plus a into x plus b is equal to x square plus a plus b into x plus ab. You can observe now by the example x plus 3 is equal to 5. That is an equation. All equations are not identities, but all identities are equations. Let us prove a plus b whole square is equal to a square plus 2ab plus b square. For this, we need the materials as graph paper, 7 by 7, scale, color pencils and glue stick. Let us consider a is equal to 5 and b equal to 2. Cut the graph paper in 7 by 7 square. This is a complete square. 7 7s are 49. A is equal to 5 and b is equal to 2. Same way observe a is equal to 5 and b is equal to 2. So now you can check. So a into a, this part is a square, which is a square which has side a and a. A into a is a square. Now let us take the rectangle which has length as well as breadth. Now length is a and breadth is b. Therefore it is a into b. Let us take the next rectangle which has length as a and breadth as b. Therefore a into b, AB is the area of this rectangle. Now see the remaining part, that is square, b into b, which is b square. Therefore we divided the complete a7 into 7 in terms of a square plus 2ab plus b square. We took the graph sheet LHS side as a plus b whole square as a complete square, which we divided into a square plus 2ab plus b square. Therefore LHS is equal to RHS. Let us see the next activity, that is activity 2. So in activity 1 already we proved LHS is equal to RHS and it has factors as a plus b into a plus b. Therefore it is a square plus 2ab plus b square. So first you can multiply a into a, then with b into b, then a into b and b into a. So see now activity 2. So our objective is to prove a minus b whole square is equal to a square minus 2ab plus b square. The materials required will be same: graph paper 7 by 7, scale, color pencils and glue stick. As here in the previous activity we took a as 5 and b as 2, where we are adding 5 plus 2. But here we are doing subtraction. From a you are subtracting b. A minus b whole square. So it is 7 by 7 square. The complete side we are taking as a. From that you are subtracting the value of b. The remaining part will be a minus b. So if you observe square here, this is a minus b whole square. That means from complete a square, so I am removing a minus b whole square. So the leftover part is a rectangle which is b into a minus b, which has length as a minus b and breadth as b. The remaining rectangular part is having b into a, where a is the length and b is the breadth. Now if you observe, from a square we are subtracting b into a minus b and b into a to get a minus b whole square. So you are subtracting from complete a square. So you are subtracting the part which is b into a and minus b into a minus b. So you will get as a square minus 2ab plus b square. So a square minus 2ab plus b square is equal to a minus b whole square. See, now we can observe LHS and RHS are equal. So this is an equation as well as identity. Now a minus b whole square is having factors as a minus b into a minus b. Therefore a minus b whole square is equal to a square minus 2ab plus b square. See now activity 3. So in the activity 3 we are proving a square minus b square is equal to a plus b into a minus b. For this same material required is your graph paper, which is 7 by 7, scale, color pencils and glue stick. So here also we are considering a as 7 and b as 2. Let us take again the graph paper 7 by 7 square. So complete from here also we are taking a as 7, but we are subtracting b as 2. So observe here, the remaining part is a minus b. Yes, now from here a square, you are subtracting b square, that small square part. Yes. So the remaining part is two rectangles, which is a minus b into a. A minus b is your breadth and a is the length. And the remaining, the rectangular part has a minus b as the length and b is the breadth. So from a square, when you remove b square, the remaining part is a minus b into a and b into a minus b. If you multiply, it becomes a square minus ba and ba minus b square. So ba and ba cancel. The remaining will be a square minus b square. That is a minus b into a plus b. You can take a minus b as common. So this part a minus b into a plus b into a minus b. So a minus b if you take common, the remaining part is a plus b. Therefore, a plus b into a minus b. From a square, when you subtract b square, you will get a minus b into a plus b. Let us observe LHS and RHS. Both LHS and RHS is same. It's verified. So now we took a square minus b square. A minus b is common. The remaining part is a plus b. So we observe now three identities. The first identity is a plus b whole square, which has factors as a plus b into a plus b. A minus b whole square, which has factors as a minus b into a minus b. A square minus b square, which has factors as a plus b into a minus b. This identity is also called as difference between perfect squares. Now the fourth identity, x plus a into x plus b. To prove this, we are taking area model. Yes, x into x, x square. This colored part is your answer. X square plus xb plus ax plus ab. So this area model is very easy for representation as well as for finding the value also.